Class 12 Mathematics, Chapter 1 Relations and Functions. Till now we have completed exercise 1.1's 6th question, continuation, 7th question. 7th question is as follows. Show that the relation R in the set A of all books in a library of a college given by R, X, Y, X and Y have same number of pages is an equivalence relation. So we have here set A of all books in library of a college. So that will write as given, find written. Then followed by the relation R. What is the relation R? That is X and Y have same number of pages. That is X and Y are the books which is having same number of pages. So such pairs we are having in our relation. What you have to prove is R is equivalence relation. So for equivalence you have to prove it's reflexive, symmetric as well as transitive. For reflexive, first we'll start for reflexive. We don't need A actually, I'll remove just A. Okay. X comma X. If book A is there, book A is having how many pages? We'll consider 100 pages. So if you're relating A with A, will the number of book pages change? No. It will be as it is. So same book has, what do you call? What do you say? Same number of pages. Is it clear? So obviously R is reflexive. Now next we'll take for symmetric we need A and B. That is two books. Okay. Otherwise leave this. We'll go for X and Y. That is better. Otherwise you'll get confused. X, book X and Y. How many pages? 100 pages. And here again 100 pages. So book Y and X, will it change? When you're relating Y with X, no, it won't change. It will be as it is. It won't change. So when you consider X and Y and X, the number of pages won't change. Got it? So obviously it is symmetric. Got it? Next, for transitive, X comma Y belongs. So this is very must. Okay, you're supposed to write this representations because even this gives you a score. Okay, now X comma Y belongs to R, Y comma Z belongs to R, X comma implies X comma Z belongs to R. We'll see. So Y consists of 100 pages. This is my second book, and the obviously its pair should consist of 100 pages. Okay, so can we say X and Z is related? Yes. So here R is transitive, hence R is an equivalence relation. So here we complete our 7th question. Go for the 8th one. Show that the relation R in the set A is equal to 1, 2, 3, 4, 5 given by R is equal to A comma B such that A minus B is even is an equivalence relation. Show that all the elements of 1, 3, 5 are related to each other and all the elements of 2, 4. It is set actually after bracket, which is not correct. Okay, 2, 4 are related to each other, but no elements of 1, 3, 5 is related to any elements of 2, 4. First part, show that relation R in the set A. What is our set A? 1, 2, 3, 4, 5 written. So we are done with this. Then R A comma B such that A minus B, mod A minus B is even. Mod means you're ignoring the negative, absolute value of the difference of A and B. We'll be considering, and that result, if even means divisible by, you can divide it by what? 2, right? So when you divide it by 2, if it is divisible, you call it even, otherwise odd. Okay, followed by, if you want, you can form the pair. Okay, so first one, we'll prove symmetric. We know that A comma A belongs to R, so A minus A is equal to 0. That is 1 minus 1 equal to 0. 0 divided by 2, 0. So divisible. So 0 is divisible by 2. So even. So that means each element is related to itself. Correct? So R is reflexive. Next comes A comma B belongs to R and B comma A belongs to R. So 1 comma 3, so 1 minus 3, 2, this is by 2, so even. 3 comma 1, 3 minus 1, mod 3 minus 1 is 2 again. What do you call? It's, what do you say? It's divisible by 2, so it's even. Therefore R is symmetric. So 2 we have passed for equivalence, and A comma B belongs to R, the third one, for transitive, and B comma C belongs to R, such that A comma C belongs to R. Okay, we'll see. 1 comma 3, find mod 1 minus 3 is 2, divisible by 2, so even. 3 comma 5, 3 minus 5, mod 3 minus 5 is 2, divisible by 2, so even. 1 minus 5, mod 1 minus 5 is 4. See, 1 3 3 5 and 1 5. Got it? So transitive, no need to think more. So hence R is an equivalence relation. This was an easy one actually. Such type, like you have done it before also. Next, second part, show that all the elements of 1 3 5. This 1 3 5 is nothing, subset of A. Okay, don't think much from where it came in all. Okay, are related to each other. First we'll check this one. So set of odd numbers, right? Odd minus odd, even. So what all numbers are there? 1 3 5. So mod 1 minus 3, 2. Odd, right? Odd minus odd, even. 3 minus 5, mod 3 minus 5 is 2, divisible by 2, so even. So they are related to each other. We'll go for now 2 comma 4. So related to each other, even minus even, even. So that is mod 2 minus 4 is 2, divisible by 2, so that is even. Next, mod 4 minus 2 is 2, that is divisible by 2, so even. So 2 comma 4 is related to each other. So when they are asking related to each other within themselves, you have to check, okay? Next, you have to check the third part of the question. This 1 3 5 is not related to 2 4. We'll see how. The set of odd, set of even. So odd minus even, odd. Mod 1 minus 2, 1, which is not divisible by 2, so not even, so not related. So same way, not related. Is it clear? So we are done with this. Now your ninth question. Show that each of relation R in set A belongs to Z such that 0 less than x less 0 less than equal to x less than equal to 12, given by 2 sub question R equal to A comma B such that mod A minus B is a multiple of 4. Second, R equal to A comma B such that A minus A equal to B. A equal to B. A equal to B is an equivalence relation. Find the set of all elements related to 1 in each case. First we'll go for the first part. In both the cases of R, we have to prove it is equivalence. For equivalence, we have to prove what? Reflexive, then symmetric and transitive. Okay. So given, we'll write the given. So our elements are nothing from 0 to 12. See Z, right? What is a Z? X belongs to Z. Set of integers. So close interval is 0 to 12. So elements will be between 0 and 12. So R is equal to A comma B mod A minus B such that mod A minus B is a multiple of 4. So with itself, image with itself, we'll check 1 minus 1, 0, divisible by 4, so multiple of 4. 7 minus 7, 0, so divisible by 4, so multiple of 4. So obviously R is reflexive, no doubt. A comma B belongs to R, then B comma A belongs to R. 4 comma 12. See, when you take the pair, you have to check whether like they are the multiple of 4. Okay, so when we check, yes, it is. So obviously it is multiple of 4. We got 8. Mod 4 minus 12 is 8, so divisible by 4, so multiple of 4. Even this pair is also multiple of 4, vice versa when we take. So R is symmetric. So we are done with reflexive as well as symmetric. Now we are moving on to the transitive. So A comma B belongs to R, B comma C belongs to R implies A comma C belongs to R. 0 comma 4. So mod 0 minus 4 equal to 4 divisible by 4, so multiple of 4. 4 minus 8, mod 4 minus 8 equal to 4 divisible by 4, so multiple of 4. Then comes 0 comma 8, 0 minus mod 0 minus 8 is what? 4? No, it's 8. Okay, so divisible by 4, so multiple of 4. So obviously, can we see it is transitive? Yes. So hence R is an equivalence relation. So we're done with it. So we'll go for the second part of second sub question. R is equal to A comma B such that A equal to B, A comma A belongs to R. So equal, okay, don't forget this thing, okay. So with itself we are checking. So it is reflexive, no doubt. So same way with itself we have the pair, so it is symmetric also, okay. So A comma B belongs to R and B comma C belongs to R implies A comma C belongs to R. We have A equal to 2, B equal to 2. We can take any value, okay. I've just taken, simply I've taken 2 and 2. You can take 3 and 3. Why 3 and 3 you're supposed to take? Because A is equal to B. That don't forget. So the value of A and B should be same. Clear? So 2 comma 2, fine. It belongs to R. But do we have 2 comma anything as pair? No, such a pair is 2 can be equal to 2, but it cannot be equal to any other number, right? So second pair is not there. When second pair is not there, when we don't have second pair when we are proving transitive, so we need not check for the third pair. With taking first pair itself, we can consider R is transitive. So hence R is an equivalence relation. Done. So we'll go for the next part of the question. Find the set of all elements related to 1 in each case. We'll see how it is working. Okay, so A is equal to 1. Now the second, here what is there in the first part? A mod A minus B is a multiple of 4. So 1 minus 1, 0, multiple of 4, right? 0 divided by 4 is divisible and it's multiple of 4. What about 1 and 2? 1 mod 1 minus 2 is 1, not divisible by 4. So we can't take. So we'll take 1 5, 4, yes. 1 9, yes. 1 13. We could have taken if a condition. What is a condition? We are only permitted value till 12. Can't exceed that, right? You can't go beyond that. So 13 we can't consider. So our set B is 1 5 9. Done. Now next, in the second case, we know that what is our second case? A comma B such that A equal to B. So A is equal to 1. Then what all values we can take for B? Only 1. 1 cannot be equal to any other number, right? Other than 1. Okay, so set B we have only 1. When a set consists of only one element, you know what do you call that? Singleton set. Okay. 10 question you are supposed to work out, because we have worked out some examples when I have given you the explanation in the beginning. So you have to work out on your own. So 11th question, show that the relation R in the set A of points in a plane given by R equal to PQ such that distance of the point P from the origin is same as the distance of the point Q from the origin is an equivalence relation. Further, show that the set of all points related to a point P not equal to 0, 0, that is origin, is the circle passing through P with origin as center? So this question has two parts. So we'll go for first part first. So show that relation R in the set A of points in a plane. So what is our set? It consists of points in a plane. Okay, so set A is equal to nothing, points in a plane. Next we have RR. R is PQ distance such that distance of point P from origin is same as the distance of the point Q from the origin. Nothing, don't think much. Point P and Q are equidistant from the origin. If this is the origin, then P and Q are at equal distance. This is at equal distance. Is it clear? Equidistance. So if you take P comma P belongs to R, A comma A will be same. That is, if OP is A, OP is equal to OP, right? With itself, we are relating it to itself. So don't think much. Okay, so R is reflexive. Now P comma Q belongs to R, then Q comma P belongs to R. If OP is equal to OQ, then OQ is equal to OP. So this is also done. R is symmetric. P comma Q belongs to R, Q comma R belongs to R, such that, implies P comma R belongs to R. We'll see how. OP is equal to OQ. Okay. OQ is equal to OR. If OQ is equal to OR, then obviously it implies that OP is equal to OR. Done. So all three override transitive. So hence R is an equivalence relation. So we have proved this. Here it's given that P is not equal to 0, 0. That is, P is not origin. The coordinates of P is not origin. P is not an origin. Okay, so where is P? P is, the circle is passing through the point P with origin as center. So what the set we have is OP is equal to OP dash. This OP dash can be any point passing through the circle. Got it? Clear? So equal to R means nothing, radius. Fine. We'll go for the 12th one. Show that relation R defined in set A of all triangles as R T1 comma T2. T1 is similar to T2. Similar. What is the symbol for similar? Okay, this is similar. Done. Is equivalence relation. Consider three right angle triangles. T1 with sides 3, 4, 5. T2 with sides 5, 12, 13. And T3 with sides 6, 8, 10. Which triangles among T1, T2 and T3 are related? We'll go for the first part first. In first part we have set A of all triangles, family of triangles, R T1, T2 such that T1 similar to T2. Okay, so first case, you have to prove that it is equivalence relation. So you have to prove it reflexive, symmetric and transitive. So A comma A belongs to R, that is T comma T1 comma T1. It belongs to R, that is T1 is similar to T1. Obviously same triangle is similar to itself, right? No doubt. Okay, so R is reflexive. A comma B belongs to R, then B comma A belongs to R. If we have triangle T1 and triangle T2, so if this is T1 and this is T2, so if T1 is similar to T2, then obviously T2 is similar to T1, right? So R is symmetry. A comma B belongs to R, B comma C belongs to R, implies A comma C belongs to R. Again, if T2 is similar to T3, Okay. So T1 similar to T2, T2 similar to T3, then obviously T1 is similar to T3. So we need not think that, okay, much in that. So can we say it is transitive? Yeah, I have not written. So R is transitive since it is satisfying the reflexive condition, symmetric condition as well as transitive condition. It is an equivalence. R is an equivalence relation. Is it clear? Okay. See, when similarity comes, when we prove two triangles similar, sides are proportional. When we are proving it as similar, the sides are proportional and angles are equal. Okay, let's see. In the second part of the question, T1, T2, T3 sides ratios are given. So T1 3, 4, 5, T2 5, 12, 13, T3 6, 8, 10. We'll see. We'll first check for T1 and T2. T1 and T2, 3 by 5, 4 by 12 and 5 by 13. They are not at all equal to each other, so they are not proportional. Sides are not proportional, so T1 is not similar to T2. We'll check for T1 and T3. 3 by 6, 1 by 2. 4 by 8, 1 by 2. 5 by 10, 1 by 2. So sides are proportional, so T1 similar to T3. That's all.